In this video, I'm going to talk about the concept of partial fractions, and there are 4 types of partial fractions concepts. For this one, I will talk about the type 1, which is the linear factors in the denominator, right? So what is meant by linear factors in the denominator? For example, you have partial fractions, you have a fraction, rational function, rational polynomial function, and you have 2x minus 1 and x minus 2, for example. Alright, so this type of partial fractions, this type of rational function, which is polynomial on the numerator and polynomial on the denominator, which the denominator you will be factorized into a 2 or more linear factors. For example, this one is a linear factors, right? Linear factors means the denominator with ax plus b, ax plus b. So they have linear factors, means more than one factors. So you have it can be 2x minus 1, x minus 2, or maybe 3 factors. So for this type of factors, for this type of partial fraction, rational function, we can rewrite it into the form of a over 2x minus 1. Means we decompose it into a over 2x plus 1, b over x minus 2. Alright, as long as this is a proper fraction, because this is power 1 here, right? The degree on top is less than the degree. After you expand, you will get a quadratic here. The degree on top is less than the degree on the denominator. So we can further decompose this into 2 fractions. So, for example, if I have 4x power of 2 minus with 2x, alright. So then I have 3x minus 1, 2x plus 1, x minus with 2. Alright, if you look at this one, this is a proper rational function. Why? So you have square here. If you expand this 3 bracket, you are getting a polynomial with degree 3. You have power of 3 cubic. So the degree here is less than the degree on the denominator. So this is called a proper fraction. Okay, proper fraction for a rational polynomial function. So if this is a proper, then you have 3 linear factors. You can decompose this into 3 fraction. So a, the first one for this one, and the second one b divided by 2x plus 1, right? 2x plus 1 followed by c over with x minus 2. Alright, so you can decompose this fraction into 3 fractions. Alright, this is called write the fraction, the polynomial, the rational function into partial fraction. Alright, this is called a partial fraction for this polynomial, rational polynomial function here. So I can give you an example. If you have 5x minus 1, it can be square, and you have x minus 1, x plus 2, 2x minus 1, 1 minus 5x. Okay, as long as this is a linear factors, x power 1, x power 1, x power 1, x power 1, all in the form of linear factors. So, and this is a proper, this is power of 2, this is power of 4, less than, the degree is less than. So you can write it into partial fraction. Alright, so hope you understand. A over x minus 1, b over x plus 2, plus with c over 2x minus 1, plus with d over 1 minus 5x. You can write it into 4 fraction. Alright, 4 fraction by decompose this one. So this is the partial fraction for this rational polynomial function here. So okay, in the same video, I'm going to teach you how to find the value of a, b, and c, right? Because you decompose it, so you have to find the value of a, b, and c. To fit, to show that this is to get the partial fraction for this rational polynomial function. Right? let's look at these examples. This is a rational polynomial function, right? This is a polynomial and this is a polynomial. And the degree here is less than the degree after you expand the denominator by x power 2, right? So for this case, you can decompose it. You can write it into a partial fraction of a form, and this is a linear factor and the linear factors. So you can write it in the form of a over x plus 1 plus with b over with 2x minus 1, right? You know that this will be the partial fraction for this function here. So, and the next step is you're going to find the value of a and b, alright? The values of a and b. So how to find the value of a and b? So you have to do the fraction. Okay, you're going to combine the fraction again. You're going to do addition for these two fractions, so into a one fraction. So for example, I recombine this as, yes, you know that x plus 1, 2x minus 1, right? So it means that if you want to add up these two, the denominator must be identical, right? So it means that this one you need to multiply with 2x minus 1, and on top you have to multiply with 2x minus 1. So it means that the a you will have 2x minus 1, right? Plus with the b, 2x minus 1, you have to multiply with x plus 1, right? In order these two to be the same. So this one also have to be multiplied with x plus 1. If these two are the same, right, the denominator are the same, so you can combine them, right? You only can start doing addition. So b over b x plus 1, right? A 2x minus 1 and b x plus 1. So now you can directly compare these two. So it means that the denominator will be the same. So of course the numerator, by comparing the numerator, right? By comparing the numerator, so by comparing the numerator, you know that x minus 3, this one, will be the same as a 2x minus 1 plus with b x plus 1, right? So you are doing comparing between the numerator and the numerator. So of course you want to find the value of a and the value of b, right? So the first techniques I'm going to introduce you is by using substitution. Alright, substitution, there are two types of method. You can using substitution, or substitute a value, or you can using comparing the coefficient. Alright, so I will introduce you the best method. So for example, I want to find a, right? I want to find a. Okay, I want to find a. So I'm going to eliminate this. Alright, so by substitute x equals to -1. Why I choosing -1? Because -1 plus 1 is 0, right? If this part 0, then I can find the value of a. So you put in here -1, substitute into right, substitute into this equation, substitute into the equation above. So you will have -1, -3 equals to a 2 times with x, -1 minus 1, right? And of course b will become 0 because -1 plus 1. This is your setting. You purposely make it become 0. So then you have -3, -1, you have -4, and here you have -2, right? -2, -1, you have -3, right? So then your a will be 4 over 3. Now you know the value of a over, you know the value of a, right? You have known the value of a. So done. So now how to find b? The same technique also I'm going to apply here. I want to find b. So what is b? So I substitute a suitable value, right? But the suitable value here will be making this become 0 because I want to find b. I want to make this become 0. So the best one will be, actually you know that to make this 0, x has to be 1 over 2, right? X has to be 1 over 2 because 1 over 2, you are getting 1 minus 1, you're getting 0, right? So substitute x with 1 over 2. Alright, so now you have 1 over 2 minus 3. Substitute into this equation here. Right? So 1 over 2 minus 3 equals to A. This one you know it will be 0 because 1 over 2, right? It will be 0. And followed by B. B is 1 over 2 plus 1, right? 1 over 2 plus 1. So here you have 1 over 2 minus 3. 1 over 2 minus 3, you will have negative 5 over 2, right? Negative 5 over 2. Okay, then you have B. Here you will have 2, right? 2 over 2. So you will have 3 over 2, right? 3 over 2. Therefore, B is equal, multiply 2 over 3 both sides. So you will have 2 over 3, 3 over 2. So become 2 over 3. Multiply with negative 5 over 2. So you have negative 5 over 3, right? B is negative 5. So now you have found B. So of course now you can rewrite this into a partial fraction. So therefore your x minus 3 over with x plus 1, 2x minus 1, you have already decomposed into A. What's your A? Your A will be 4 over 3, right? 4 over 3 x plus 1, right? Followed by B. B, it will be negative 5 over 3. Negative 5 over 3 divided by 2x minus 1, right? So then if you rewrite this whole thing, your x minus 3 over with x plus 1, 2x minus 1, the 1 over 3 and the negative 1 over 3, I can factorize 1 over 3 out. 1 over 3, 1 over 3, or I can just write it become 4 over 3. 4 over 3. Remember to put bracket because the 3 belong to x and 1. And positive negative, you have negative 5 over the 3. I put with the denominator will be 2x minus 1. So this will be the partial fraction for this polynomial rational function here. So I will give you another examples in the same video. Hi, this will be the second example for this type 1 linear factors in the denominator. So let's look at the rational function here. So you have degree 2 here, right? So you have 3 factor, linear factor. If you expand, you are getting a cubic, right? Means that the x will be cubed. The degree here is less than the degree on the denominator. So this case will be considered as a proper rational function, right? So and after you confirm that this is a proper rational function, you can further decompose this rational function into smaller fraction, right? This is considered complicated. So a over x minus 2 plus with b over with x plus 3 plus with c over with x plus 5, right? So this will be the partial fraction for this rational function here. You must know that this is a linear factors. You must see that this is a linear factors, then you can do it easily just by writing it in this form. So now I'm going to recombine this fraction, right, and getting back to here. So you know that everything, if this one you have to multiply, this one you have to multiply with x plus 2, right? You have to multiply with x plus 3 and x plus 5, right? Because you want to get back this, right? So you already have x minus 2, so you need to multiply these 2. So also, the same also for on top, you have multiply x plus 3 and x plus 5. Alright? So means below you have x minus 2, x plus 3, x plus 5. Right? So the A will be, your A will be x plus 3 multiply with x plus 5. Right? How about B? you look at the denominator b. You have x plus 3, you have x plus 3. So means you need to multiply with, you already have x plus 3. You need to multiply with these two factors here, right, to get this. So you multiply with x minus 2, and x plus 5. X minus 2 and x plus 5. This is in your mind, right? So b, x minus 2, x plus 5. This is a concept of fraction, right? It's a concept of fraction. So again, you look at this c, x plus 5, you have x plus 5, right? You have x plus 5. So you need these two, right? You need these two. So you need to multiply with x minus 2 and x plus 3. X minus 2 and x plus 3. So c, x minus 2 and x plus 3. Alright, and you double check whether correctly multiply or not. So if you observe the check, you see yes. Alright, so now you compare. After you see that you can do comparing because the denominator are the same. So now you have to compare the numerator so that you can get the value of a, b and c. So by comparing the numerator, okay, so you know that x squared minus with 2x plus 3 will be equals to a, right, the numerator and the numerator here, x plus 3 and x plus 5, and b will be x minus 2 and x plus 5, plus c, you will have x minus 2, x plus 3. So very easy. Now you are doing comparing. So we will repeat we were using the same technique for the example just now. So if you want to find a, right, we have to do it slowly. If you want to find a, right, so you find a, you have to make the term here, the second term and third term here become 0, so that you can find the value of a, right? So let's look at the b and c. You have a common factor, right? You have x minus 2, and this also have x minus 2. So if you put x equals to 2, what happened, right? If you put x equals to 2, I'm not going to see this one, they are different. So these two are the same. So I put x to 2. If I put 2, 2 minus 2 is 0. 2 minus 2 is 0. These two terms will become 0, right? Then you can peacefully find the value of a. That's the technique. So you substitute, find a, you substitute x equals to 2. Why are you choosing 2? I have already tell you, if you put 2, this 2 will be 0, right? So you put 2 into the equation, right? Into this equation. So you tell them, you substitute. So you substitute, then you have 2 to the power of 2 minus 2 multiply 2 plus 3. Substitute into the left hand side to the right hand side. So a, 2 plus 3, 2 plus 3 and 2 plus 5. So then if you calculate here, you have 4 minus with 4 plus 3 equals to a, 2 plus 3, 2 plus 3, 5, right? 2 plus 5, 7, right? So then you have 4 minus 4, 0. So you have 3. So it means that a will be 3 over 7 times 5, 35. Then you will have questions. So where is the b and c go? Because you are putting 2 into these two terms, of course it will be 0, right? The whole thing here. So a will be 3 over 35, right? Okay. Now you find for b. Now you want to find for b. So the same technique also, I'm going to substitute a suitable value. Substitute x equals to something here. So then you have to observe. You want to find b, right? You have to make these two become 0. This and this one becomes 0. Then you see, what is the common factors here, right? What is the common factor between these two? Is x plus 3 and x plus 3, right? So you want these two to be 0, you have to substitute x with negative 3, right? Because negative 3 plus 3 is 0. Negative 3 plus 3 is 0. So that's why you choose negative 3. So now you're putting negative 3 square into your equation. Negative 3 plus with 3. Right? You substitute negative 3. And here you know that negative 3 plus 3 you have 0. So then you're left with only the second term. So negative 3 minus 2, right? Negative 3 minus 2 and negative 3 plus 5. Negative 3 plus 5, right? Okay, slowly. Here you have 9. You have 9 plus 6 plus 3, right? You have 18 here. 18. 9 plus 6 plus 3. So you have 18 here. So here you will have negative 5 multiplied with 2, right? Negative 5 multiplied with negative 5 multiplied with 2. So you have 10. Negative 10, right? So then B will be 9 will be 18 over with negative 10. You have negative 9 over 5, right? 9 to 18, 5 to 10. So you have found the value of B. Now go for the last one. You want to find C. The same step you apply here. Find C. So you have to substitute x equals to the value that can make these two become 0. You want to find C, right? So you look at for the common factor between these two, the first two terms here. You will have x plus 5 and x plus 5, right? So the best is substitute x minus 5, right? I hope you understand by now, because negative 5 and negative 5 will make these two become 0. So you will have negative 5 square, negative 5 square, substitute into here, and 5 square minus with 2 times with negative 5 plus 3, and equals to, these two will become 0, right? Negative 5 plus 5, 0, negative 5 plus 5. So you substitute into here. So C, negative 5 minus 2, negative 5 plus 3. So you have 25 plus with 10, 25 plus with 10 plus with 3. You have 38. 38 equals to C. This one you have negative 7. This one you have negative 7. Negative 7 multiplied with 2, right? Be careful. Negative 7 multiplied with negative 2, okay? Multiplied with negative 2. So you have 14 here, right? You have 14 here. Be careful when you calculate the number here. So, alright. Negative 7 multiplied 2, you have negative, you have positive 14, right? Positive 14, negative, negative, positive. So C will be 38 over 14. 38, 14, after simplify, I think you will have 19, right? 38 over 14, you will have 19 over 7, right? 19 over 7. Okay, done. You have find the value of A, B, and C. So you have to rewrite your conclusion, right? You have to rewrite your conclusion. So I'm going to write here. So because you have already finally decomposed this fraction into, therefore, x squared minus 2x plus 3 over with x minus 2, x plus 3, x plus 5 is equals to A, right? Your A will be 3 over 35, right? You know this one will be 3 over 35. So we rewrite as 3 over 35. Put the 35 on the denominator, or x minus 2, right? X minus 2. And look at the B here. Negative 9 over 5, right? Negative 9 over 5. So here we negative 9 over 5. Positive, negative. Negative 9 over 5. Bracket. The factor will be x plus 3, right? Followed by C. Positive 19 over 7. 19, here will be 19 over 7. So the 7 and bring it here. So it becomes positive 19 over 7 x plus 5. So this will be the partial fraction for this polynomial rational function, right? You have further decomposed this into a simpler fraction, right? So I think that's all for this video. This is just type 1, all right? We have another more 3 types. So hope you follow all the videos and you will be very competent in solving problem involving partial fraction.